Okay, so for example 20, it's actually quite similar to what we already did in the previous example. Okay, however, this one actually just leads to generalization or rule, if you will, as to how to obtain an expected value. Okay, in example 19 in the previous video, I kind of just told you that to get the expected value, what's the rule involved? You multiply these numbers, if you recall, and then you add them all to each other, and then you divide by how many you have. Okay, we kind of discovered that, or I just kind of told you how that's the way to solve it. But really, in mathematics, there is actually a rule that tells you that you're supposed to do that. Okay, and that is what's found in this box in your textbook. Okay, the expected value E of x is equal to mu. This is our standard variable for average, and if you recall from the previous example, we kind of got the average already. Okay, in fact, we did get the average, and that is defined by the summation. So this is the symbol for the summation of all of your x values, okay, multiplied by the probability of each one happening. Okay, and that's, again, going back to this example, that's exactly what we did. We multiplied it by the expected, or the chance that it will happen over a number of trials. So the reason why it's a summation is because you're adding up all of the possible answers, the products, from the number you're starting with all the way to the number you're ending with. Okay, so if I only had one value, if x equaled 1, then I wouldn't have to, add anything. I would just use this formula, ignoring that summation sign, and that would be my answer. But if I had two values, then I would have to do this twice for different values of x and then add them. Okay, that's what the summation symbol means. You're adding each of those separate answers to get a total. All right, and here in example 20, okay, you can read this, but I'm just going to focus on the table here. My allowable values for S will be 2, 3, 4, 5, 6, and then they give me the corresponding probability, right? The probability distribution, and then they're just asking us to find the expected number of newspapers and then interpret what it means. Okay, so if you look at the solution, okay, these numbers, the 2, just came from this one over here. Okay, and then they multiplied it times 0.05. That also just came from this cell over here. Okay, so I'll use a pencil so I can write on this textbook. Okay, 2 times 0.5, that's grouped together, and then I have 3 times 0.39. Again, these values are just from the table. Okay, and so on, and I have my answer. Okay, this may look fancy, but really all you're doing is just multiplying each of the columns, if you will, with each other, so the top and the bottom. Okay, and then you're adding all of those products to get the total answer. Okay, and then the interpretation is as such, on average. So this will give us information on the average. Okay, so whenever you see this, okay, if you recall here, notice that this is actually equal to this. So what that means is that this will give us the average of all of my trials. And then here it also says that there is more than a 50% chance that she will sell more than her regular order. So just study this, and you should be able to proceed with the examples and exercises.